In the next couple of videos, we're going to review the following topics. We're going to review how to graph an equation, by plotting points, we're going to review how to find the x and y intercepts of a graph, and we're also going to review how to determine if a graph is symmetric. And there will be three types of symmetry we'll review. A graph being symmetric about the x-axis, a graph being symmetric about the y-axis, and a graph being symmetric about the origin. So let's look at the first topic, graphing an equation by plotting points. So what I'm going to do is I'm going to give you an equation and two variables. So that's what we're going to be studying. Equations in two variables. And the two variables I'm going to give you for this section are x and y. So an equation in two variables can look like many things. We could have something like x plus y is equal to 3. Or maybe x squared minus 7y is 8. Or we could have something like x divided by y is 10. Any kind of equation meaning we have something relating x and y and we have an equal sign. That will be an equation in two variables. The first equation I'm going to give to you is actually a line. And the line is x plus y is equal to 3. We know we have a line whenever the power on x and y is 1. So you can see here the power is 1, the power is 1 here. You have both an x and a y and the power is 1, you've got a line. So let's try to graph this by plotting points. I'm going to put the xy coordinate system here. Let's move this right here. And let's see if we can graph this. So to graph something by plotting points, we've got to figure out the x and the y such that when we add them together, we get 3. So maybe you can think of two numbers, an x and a y, and when you add them, you get 3. Let's say x is 2, y is 1. Well, 2 plus 1, following this right here, that is equal to 3. And this corresponds to the point 2, 1, because this is the x coordinate and this is the y. So let's put a point on the graph at 2, 1. So 2, 1. This is a point on this graph. Now there's lots of points that go to this graph. In fact, there's infinitely many points that belong to the graph. Let's find another one. The easiest thing to do is to solve for one of the variables. Usually we solve for y. So let's move the x over to the other side. So y is equal to 3 minus x. And let's just plug in whatever we want for x. So maybe x is equal to, let's say 7. What do we get for y? Well, if x is 7, y is 3 minus 7, which is negative 4. So that tells us when x is 7, y is negative 4, and we have this point. So let's graph this point, 7, negative 4. So here's 5, 6, 7, and we go down 4. That's another point on the line. Let's keep this line written like this, y is equal to 3 minus x. And let's find another point. Choose any number other than what we've already done for x. So we've done 2 and we've done 7, maybe we can plug in 0. So when x is 0, we can see that y is 3. So we have the point 0, 3. So let's put a point at 0, 3 right here. And you can continue doing this. So let's do one more. Maybe let's let x be a negative number. So if x is negative 5, y is 3 minus a negative 5, which is 8. So negative 5, 8. We put a point, negative 5, 6, 7, 8 right here. And you can see as you do this, you're going to have infinitely many points. They're all going to be along a straight line. So what you can do is draw a line through all of these points. In fact, when you know that the equation of something's going to be a line, you really just need to find 2 points and then just draw a line through them. And you want the points to be kind of spread apart. That way you get a really nice line. So maybe like this point and this point, you can see what the line's going to look like. You don't want to get 2 points that are really close together because it's going to be hard to draw the line. But I'm going to try my best to draw a straight line using this software I've got. So it looks something like this, and it's going to go on forever in both directions because you can put infinitely many numbers in for x. You can put lots of positive numbers. You're going to see whatever you get, the bigger it is, the smaller the y is. It's going to be more and more negative. And if you put something negative in for x, you can see that you're going to get a positive y, and this is going to go in forever this direction. So this is the line y is equal to 3 minus x. All right, so something you'll see on your homework is they'll ask you if a particular point is on the line. Let's stick with this, y is equal to 3 minus x. So something I could ask you is the point let's say 7, 7 on the line? I could write it as y is equal to 3 minus x, or x plus y is 3. Well, visually, you can look at this graph. Now that we've plotted it, you can see that 7, 7, where is that? 7 is here, then we go up 7, which I think is right here. Obviously, this point is not on the graph. But you could also plug it into your equation to see that it's not on the graph. Because if you say, well, 7, 7, is 7 equal to 3 minus 7? Is that a true statement? Well, 3 minus 7, that is negative 4, and 7 is not equal to negative 4. So no, this point is not on the graph. Let's choose one more just for fun. Let's say, is the point 1? No, let's not do that one. Let's do 3, 8. Is this point on the graph? And the answer is no. Why is the answer no? Because 8 is not equal to 3 minus 3. Putting in the 3 in for x and the 8 here, you can see 8 is not equal to 0. But if you get something like 1 and 2, you'll get a right answer. So if you try the point 1, 2, you'll see that 2 is equal to 3 minus 1. That's a true statement. So that point is on the graph, and you can see it right here. Here's the point 1, 2. Okay, let's try another graph. So I'm going to put my plane right here, and let's try to graph y plus x squared is equal to 4. What is this going to look like? Again, we're going to plot this by just plotting points. That's how we're going to graph it. So what I would do is I would solve for y. So y is equal to 4 minus x squared. And what you're going to do is you're going to just choose something for x and see what you get for y, and then you'll have an x and a y coordinate, and you'll be able to plot a point. And later on, we're going to learn how to graph these equations in an easier way. Right now we're doing a lot of work to graph an equation, but we're going to learn some tricks that will help us graph it a lot quicker. Okay, so let's choose an x. Let's say x is equal to 0. That's always the easiest thing. What do we get for y? Well, y is 4 minus 0 squared, which is just 4, so we have the point 0, 4. Let's plot that point. 0, 4 is right here. Let's try another one. Let's say x is equal to 1. What do we get? Well, we get y is equal to 4 minus 1 squared, so it's equal to 3. So we have a point 1, 3. So 1, 2, 3, right here. Let's choose another x. Let's say x is 5. Actually, that's a little too big. Let's go with x is equal to, let's go with 2. Okay, so if x is 2, we'll get that y is equal to 4 minus 4, because 2 squared is 4, and we get y is equal to 0. So we have the point 2, 0. So 2, 0. And let's do one more that's positive. How about when x is equal to, let's go with 3. So then y is equal to 4 minus 9. So y is equal to negative 5. So we have the point 3, negative 5. So let's put that point right here. Okay. So something you'll notice is this graph is obviously going down, but it's not a straight line. You can see already that if we try to start drawing something that goes through these points, we're going to get a curved shape. Something like this. And you could continue to draw this. But actually we're ignoring half the graph. When you choose points, you also want to choose some negative points to get a full picture of this graph. So let's choose something negative for x. Well, let's go with negative 1. So if x is negative 1, what do we get for y? So y is 4 minus a negative 1 squared, or 4 minus 1, which is 3. So we have the point negative 1, 3. Let's plot that. So negative 1, 3, it's right here. So here's another point. Now, since we put in a 2, let's also put in a negative 2 for x. Okay, so when x is negative 2, what do we get for y? Y is 4 minus a negative 2 squared, which is 4 minus 4, which is 0. So we get negative 2, 0. And you'll see if you put in 3, you'll also get a negative 5. So we can put a dot right here. And so you see that you're going to get the same picture as you get on the right side. You get it on the left side. So something like this. This is what we call a parabola. And let me write the equation of this parabola here. So this equation is actually symmetric with respect to the y-axis, meaning that if you folded this graph in half along the y-axis, whatever you get on one side, on the right side, will lie exactly on the left side. So folding in half, they'll overlap. We'll talk about that a little bit more later. Let's try to graph one more equation. Okay. So let's try to graph y is equal to x cubed. What will this look like? So now I think we have a good idea of how to plot points. So what I would do is choose about 3 positive x points and 3 negative x points and see what the graph looks like. So I'm going to go with x is equal to 0. That's always a good one. X is equal to, let's go with 1. And x is equal to 2. What do we get for y each time? So y is going to be 0 because 0 cubed is 0. For x is 1, y is going to be 1 because 1 times 1 times 1 is 1. And then when x is 2, we're going to get 2 cubed. which is 2, 3 times, which is 8. So let's plot these points, 0, 0, 1, 1, and 2, 6, 7, 8, right here. And you can plot more points if you want to, but this graph is going to look something like this. So now let's choose 3 negative x values. Let's go with -1, -2, and we can do -3 as well. So when x is -1, we're going to take -1 and cube it. So -1 cubed, that's going to be -1. So we're going to put a point at -1, -1, -1, -1. Then you can do this, y is -2. You'll see that you'll get -2 cubed, which is -8. Okay, so we're going to put a point at -2, 8. Right here. And then, of course, you can do this last point. You don't really have to do this one. I think you're going to get an idea of what it looks like. But this is going to be y is -3 cubed. So that's 9 times 3, which is -27. So it's 9 times a -3, which is -27, which is way down here. We don't even have to graph that. It's not going to appear on the graph. So what you're going to get, if you zoomed out in this graph, let me put it over here, what you're going to see, if you plot this, is a graph that looks something like this. So whatever you have here is, there's a mirror image on this side right here. This is the origin. So this is what we call symmetric about the origin. It's not symmetric about the y-axis, because if you folded this in half, you could see that this piece is not over here. And it's not symmetric about the x-axis. If you folded this graph in half here, this piece wouldn't show up down here. But it's symmetric about the origin. So if you, I guess this, whatever you see here, it's flipped and put on this side here. Okay, so we know how to do a very brute force method of graphing an equation. You just plot some points. And you have to actually, like, if you have no idea of what the graph looks like, you probably need to plot a lot of points. Because, for example, the last problem we did, if we had only done maybe this point and this point, you said, oh, just graph 2 points, you might think you have a line. And even if you had done 3 points, you was like, well, maybe it's just half the graph, you know, it looks something like this. You don't know what's happening on this side. You had to plot some negative points. So you can see that we plotted at least 7 points here to get an idea. And for this graph, we plotted 5 points, and we have a good idea of what it looks like. The more points you plot, the better the graph you're going to get, the more accurate of a graph. But what we're going to learn is we're going to have certain functions or certain equations like this one where we're going to memorize what it looks like. And then we're going to talk about moving the equation and stretching or condensing the equation to get a better picture of the graph. So things, if we change this to something like y is equal to x cubed plus 7, we'll know what to do because we know the basic graph. We'll know what this graph looks like too. It's kind of hard to see. Let me write it over here. So if we had something like this, we're going to learn how to graph that without actually plotting points. So let's move on. Let's talk about finding x and y intercepts. So how to find x and y intercepts. So first we need a definition. What is an x or a y intercept? So intercepts are the points where the graph touches or crosses the axes. Remember, we have an x-axis and a y-axis. So if we touch or cross the x-axis, we're going to call it an x-intercept. And if we touch or cross the y-axis, this is called a y-intercept. So touch cross x-axis, we have an x-intercept. Let's look back at the graphs we've already done. Let's see if we can figure out some x and y intercepts. Let's start with the very first one. Let's move back. This x plus y is equal to 3. Where do we touch the x and the y axis? So look very closely. So here's the y axis. We touch this graph right here. Can we figure out this point? What is this point? And also notice that we touch the x-axis. It looks like somewhere around here. What is this point? Those will be our y and x intercepts. Let's see if we can find an answer for that question. What is the x and y intercept? Let's start with the y-intercept. So that's where we cross the y-axis. Now, sometimes a graph, just looking at it, this one's going to be easy, but sometimes it doesn't cross at a nice number. You can't really see. It might cross, let's say, halfway between the 4 and the 5 or something like that. So you need a way to find that point pretty easily. And all you have to do is notice that when it crosses the y-axis, that would force this x to equal 0. So to find the y-intercept, we need to plug in x is equal to 0 into our equation. So our equation is x plus y is equal to 3. And we solved for y. We said y is 3 minus x. So if we plug in 0 into x, we'll get y is equal to 3 minus 0, which means y is 3. So we cross at 0, 3. That is our y-intercept. And we found that point earlier. So a y-intercept is when your x is 0. Let's change this to what is the x-intercept. Well, that's when we touch or cross the x-axis. So what do you think we need to do to figure out the x-intercept? Well, if we touch the x-axis, that means y is forced to be 0. So that's where y is equal to 0. So our equation was y is equal to 3 minus x. Let's plug in 0 for y. So 0 is equal to 3 minus x. We can move the 3 over, or we can move the x over, and we get x is equal to 3. So this point here, and it looks like it's correct, is 3, 0. This is our x-intercept. Okay. So we could just look at this graph and tell what they are. How about this graph right here? This is the parabola. We said that we could solve for y from y plus x squared is 4. Solve for y, we get 4 minus x squared. Let me get rid of this so we can just see the graph. I want to know the x and the y-intercept. So what is the x-intercept and the y-intercept? And it doesn't matter which one you find first. It's usually easier to find the y-intercept, especially when it's written in this form. To find the y-intercept, you just plug in 0 for x. So So we set x is equal to 0 for the y-intercept. We get that y is 4. So 0, 4 is our y-intercept. And you can see that right here. Maybe I shouldn't do it in white. Let's put it here. This is our y-intercept. What about an x-intercept? Now you can have more than one y-intercept or more than one x-intercept. In fact, you could have no x-intercepts and no y-intercepts. For this particular problem, we have 2 x-intercepts, and we found them earlier. We said they were 2, 0 and negative 2, 0. But how would we find them from the equation? Well, we just plug in 0 for y. Let's do that just so that we understand how to find the x-intercept from the equation. So we set y equal to 0. So we get 0 is equal to 4 minus x squared. Let's solve for x squared by moving it to the other side and take the square root. Now when you take a square root, you get a positive and a negative square root of 4, which means x is equal to positive or negative 2. So you're going to get 2 options. So that tells us that when x is 2, we get 0, and when x is negative 2, we get 0. So those were our 2 x-intercepts. Okay, let's look at the last one, this graph here. Looking at this graph, can you find an x and a y-intercept? The answer is yes. There's one x-intercept and there's one y-intercept, and they happen to be the same thing. So the x-intercept is where we set y equal to 0. So we get 0 is equal to x cubed, which tells us x is equal to 0. So the x-intercept is 0, 0. For the y-intercept, we set x equal to 0. So y is equal to 0 cubed, which is 0. So we get the point 0, 0. So the x-intercept is the y-intercept, which is right here, the origin. Okay. I am going to give you a graph, and I want to see if you can find the x and y intercept just by looking at the graph. So let me put the xy plane here, and I'm just going to draw something for you. Now I'm not going to give you an equation to this. Okay, so here's some graph of some function, or a graph of a equation, and I want to know what are the x-intercepts and the y-intercepts, at least from what you can see. And how many are there? So let's see, we have one y-intercept, and that's where we cross the y-axis. I'm going to put a dot here. You can see from this graph, it looks like the y-intercept is 1, 2, 3, 3 down, so 0, negative 3. What about x-intercepts? Well, here's the x-axis, and we count how many times it crosses the x-axis. Here it crosses 1 time, 2 times, and then 3 times. So we should have 3 x-intercepts. Now let's see if we can kind of give a point for these. Here's negative 5, negative 6, negative 7, so negative 7, 0. And then right here, now look at this one. This is sitting somewhere in between 1 and 2. If I don't have an equation for a graph, I'm going to have to guess. To me, it looks like negative 1.5, because it's right between negative 1 and negative 2. So that's what I'm going to go with. But if I want to be precise, I need to have the equation of this graph. The last x-intercept looks like 1, 2, 3. So 3, 0. So now we have all the x and y-intercepts. Okay, let's draw another one. I'm going to draw, let's put it right here. I'm going to draw a circle. How many x-intercepts and y-intercepts do I have? Well, I have 2 x-intercepts and 2 y-intercepts. What are they? 1, 2, 3. You can see that the radius of this circle is 3. So my 2 x-intercepts are 3, 0 and -3, 0. And my 2 y-intercepts are 0, 3 and 0, -3. Remember, you need to be careful of the order of these. The x is a number, and this one's forced to be 0, then they're x-intercepts, okay? And they go along the x line. When this number is something other than 0, you're going along the y-axis. Something you'll see in your book and on your homework is they'll refer to x-intercepts as roots or zeros of a function. So let's write this down just so that you're aware of this. X-intercepts are also known as roots or zeros of a function. And we'll talk about what a function is later. You could also say roots or zeros of an equation. Maybe we can put that here. So if I ask you for the roots of this circle, or if I ask you for the zeros of this circle, you're going to give me the x-intercepts. Okay, so you're going to say 3, 0 and -3, 0. Let's go back to the one above. If I asked you for the roots of this equation, y is equal to x cubed, you'll say 0, 0. That's the x-intercept. Let's go up one more. What are the zeros of this equation, this parabola? You're going to tell me, oh, it's -2, 0 and 2, 0. So x-intercept also means roots, also means zeros of a function.